So software security is really, really hard. It's really, really hard to develop rugged software. And why is it so? I mean, we've been trying to do that for a long, long time. And I think one of the reasons for that is we're addressing it as a technical problem. It's not really a technical problem, it's a cultural problem in your development organization. So my name is Stefan Andersson. Me and my colleagues, Fredrik, Svante, we will talk a little bit about how we are trying to integrate software security in the development culture at our company, Axis. So Fredrik will start out. He will talk a little bit about history, a little bit about the background, the stuff that's important to us, why security is important, and a little bit about the philosophy we have for our security program. I will talk a little bit about our toolkit, the development model we're using, and Svante will bring in the developer perspective. So me and Fredrik's sort of half-time architect, half-time full security guy, and I'm a security coach full-time. And Svante is the developer perspective in all of this. So since it's a developer conference, we needed to bring a developer on stage as well. So Fredrik, do your thing.
Yeah. So I'm going to talk about a bit of a background while we're doing this. And as Stefan said, it includes a bit of company history. I know that's why you came here to listen about our company history. But I think it's important that you hear this so you can understand why we've chosen to do certain things in certain ways. So Axis was founded way back in the 80s. So it's quite an old company and started out doing a device like this. And this is a printer protocol converter. And you connected it to a big expensive machine like this. This is an IBM mainframe. So instead of having to buy IBM's big expensive printers, you could connect this converter and you could use your PC printer instead. Not terribly important for this presentation, but here for completeness. But during the 90s, Axis did this, and this is a print server. So you connected this to your local printer, and then you could connect that to the network, and you could print everywhere. And this was a big thing, at least for Axis, and they thought it was a really great idea to be able to connect your things to your network. So they created the concept of a thin server. You create a small embedded server that you can connect to the network, and you connect that to the device. Kind of similar like Internet of Things. I would more call it LAN of Things, given how the networks looked in those days. But through this concept, they looked into connecting more things, like scan servers and CD-ROM servers and jazz drive servers and all that cool technologies from the 90s that no one ever uses anymore. But in '96, Axis did the NetEye 200, and this was the world's first network-connected video surveillance camera. And this is what we're known for today, and this is by far our biggest business. If you look into a modern one of these, you will find that it runs typically between 10 to 20 million lines of code, so it's quite a big, complex system. It has a lot of open source. We wouldn't be able to do it like we do it today without all that open source. We're a big Linux shop. We have used Linux since '97, I think. We use big open source projects like Apache and OpenSSL. We're big contributors to GStreamer. And we also do our own hardware. So we do electronics and we do our own SOCs. And we even do, we even have our own processor architecture called a CRIS. And this is not really our main processor anymore, but it's part of the modern chips. These are multi-core, so it's there on the chip as a support processor for the image pipeline, but we use ARMs these days. And we do mechanics, so we basically do everything except the lenses and the sensors. And we don't only do one video product, we do hundreds of them. And we do more than video products. We do access control systems, we do speakers, we do radars, and all of these things are network connected. And we do solutions, so you can connect them together. So we have Windows clients, we have Windows servers, we have network storage and switches. These are the boxes there. They are third-party produced, but they're branded like Axis, so it's for us. We do mobile apps, and of course we do cloud. So what does this mean for security? I mean, we have hundreds of products, different product types. We have Windows clients and servers, we have embedded Linux, we have hardware, we have cloud. It's quite a lot of things that we have to take care of when we look at security at our company. So we've been doing networking for quite a long time. Should we be pretty good at security at this point? We should. And we're doing all right, I'd say. But it has mostly been because of smart developers and quality conscious. Because we're very concerned about our quality, we need to have high quality. These products are expensive. And also, but this hasn't been a really big issue for us. And the reason for that is that customers haven't really been that worried. Our biggest customer segments are big enterprise enterprise systems, where they put these on corporate networks, behind firewalls and VLANs, and they're fine with that. They don't really care what we do because they've secured the system anyway. These things are changing. They don't really trust that anymore. Not all of these cameras are put on separate VLANs anymore. It's moved into production network, and people bring their own device to work and put up access point and all of that. So the business really understands now that we can't really protect that perimeter defense. So that means we need to step up our security game. So we need to be able to secure the devices, because nowadays all devices need to be able to stay secure by themselves. And I think that's really good. Another thing, when you look at all this technology, Axis is a large company, but it's not that large. We have an R&D section that's about 1,000 people that does all of these things. And we did that even when we were half that size. And I think one of the big reasons why we were able to do that much is because we put a lot of trust and faith into our developers and a lot of independence to development teams. And that's part of our culture, something that we want to keep, so that the developers and the teams can work independently. One side effect of this is that we probably tried out every known collaboration tool known to man in one team or another, but overall, the gains outweigh the cons. So how would we approach these teams when we want to do our security work? You could consider doing the bad cop, good cop, or look at these different types. Would we want to be the bad cop, kicking down the doors, beating everyone up, and then hand them a policy document? Or do we want to be a good cop, more like we like to use the positive imagery of the English Bobby, whom you can ask for directions and likes to help old ladies cross the street. And we think this is really important because we want to make developers feel that we are on their side. We're not opponents, so they come to us, ask for help, so we can work together on problems instead of them spending their time trying to avoid us and avoid security work. And we took all this into consideration when we looked at how we wanted to do our group. So we want to form this security group to do the security work. And one point of view, or one model, is to do the centralized way, where you have one group of security people getting stuff fed from the R&D and trying to make them secure afterwards, and ultimately fail, because that's what you usually do. Also, if you remember the slide where I showed all the different technologies we use and the different domains, what kind of expertise would we need in this security group? I mean, we have process architecture, we have cloud, we have Windows, we have embedded Linux. It would put a pretty big high requirements on that group to have all that expertise in there, because you need to have domain knowledge if you want to get accurate results out of your security work. Also, we were pretty sure that this would introduce a bottleneck. I mean, Axis, like most other companies, are very concerned about speed, and we were pretty sure that if we have a big R&D team just feeding in things into this, it would impact speed and introduce a bottleneck. And it would also impact the independence and the autonomy of the different groups, something that we have in our culture today. We don't want to really change that. So we never really considered that model. We went just straight for the distributed one at once, where it's the team that does the security work. The team is responsible for the security work, and the security group is just there to help out, to coach, to give best practices and tool sets and methods of doing that security work. It also means that the team owns the problem. It owns the security of whatever they are doing. It's not someone else's problem. How many here knows about the Google Beyond Corp initiative? One. Good for you. So anyway, Google, they introduced this Beyond Corp where they said that all their internal services like time report systems for employees would be put outside the intranet onto the internet. And the reasoning here is that because if you're doing it for the internet, you might get that false sense of security that someone else will do the security for you. So if you put it on the internet, it's on you. We want to do this here as well. There is no one else that's going to fix the security for you. You have to do it yourself. But Axis, as I said, has a fairly large R&D organization. We have a very few, very small remote sites, so most of it is located in southern Sweden, in Lund. But still, it's about 40 teams, so it's quite difficult to reach out to all of them to work on them on a regular basis. So we have something that we call satellites, and Svante is one of those. Developers that are embedded in the team, they're actually from the team, but they have a special interest in security that we can work closer with. And we try to meet them up on a regular basis, discuss what's happening, discussing new techniques, how it's going with the security work, having external speakers come in to us so we can do some knowledge sharing. So that's the way we've set up our security work. And our responsibility in the security group is to make the R&D organization able to do the security work, not the result of the security work, really. But there's one thing that we do have centralized, and that's the vulnerability management. And this email we got, I don't know, 3 or 4 years ago, while we were discussing how to do our security work. So we were already looking into this, and during that time we got this email. And it's a guy claiming, who calls himself Bashis. He says that he's found a critical vulnerability. It affects all our products, I mean hundreds of products. And he's done this through downloading the firmwares from our website, loading them into an emulator, tailoring the exploit for each one of them. And here you have this critical vulnerability. And we looked into it, and it was true. And we saw that the bug was introduced 6 years ago. So it affected all our releases 6 years back. We had to do more than 200 firmware releases after this. And this was a pretty sophisticated attack as well. He used techniques like return-oriented programming. He beat ASLR. He circumvented no execute map memory. So it was pretty advanced, and he had spent 6 months of this. And that was a pretty good wake-up call for us, that someone had actually spent that time and effort on hacking our devices, to go through all that to hack our devices. And I thought it was timing was kind of convenient, because we were looking into how important is security, how much effort do we need to put into this, and this email came. So it's actually pretty good. And it turned out he was a good guy, so we worked with him, had good communication, we did the responsible disclosure, we fixed it. We notified all our customers, which isn't really easy for us, because many of our customers, they don't want to update the firmwares. We would like them to do that, but they don't want to, because they have to validate the software that it works in their systems. In case of airports, they would like to run these new software versions in a test system for 6 months without operational failure before they put it in production. So that's kind of a problem for us. So we have the reactive side that we had to create when we got that. We hadn't had an issue really for 10 years, so we were kind of unprepared, and we had to create our vulnerability management on the go. Fortunately, we were already looking into security, so we had a few people that was ready to do it, so it all turned out right. But it is costly. It's difficult to do, so you really want to put as much as possible on the proactive side. But you still need vulnerability management, because it doesn't matter what you do, there will always be insecurities. This slide is from an internal awareness training we did at Axis. So to the left we have our CTO, and to the right our R&D manager. And those two guys together with me and Stefan, we did this awareness training for all the developers at Axis, all software developers. So this was something about 600 or 700 software developers. We did this together with them. And that was really good, because you need this upper management backing. You won't be able to have a security program or security initiative if you don't have management backing. So if it's a few engineers that think this is important, it won't work, because you need everybody on board. Everybody needs to prioritize this. There will always be these discussions about features, contra security, and you need that backing, otherwise you will lose out. And we do have this fantastic support from Axis, so we're really fortunate. So together with management, we drew up these principles to build our security work upon. One of them is build security in, so we want this to be a part of our development and design, not something that you try to bolt on afterwards. We want it to be risk-based, so we prioritize our efforts on the things that carries the most risk, instead of trying to fix everything, because that won't work. Then we won't have time to do any development at all besides security. We want to do it through coaching, not having policies, but go out to the teams, learn the methods, give them tools, give them best practices, and empower the teams to do the security work. And we want to be transparent. And this is both internal transparency, so when we have issues or incidents or vulnerabilities, we're not trying to keep things secret, because we want everybody to be involved in security work, then we can't really keep secrets. I mean, there's a risk about that being too transparent, but we see that the gains, again, win over the cons here. So we like to trust our employees in these cases. And we also try to be transparent outwards. So when things happen, we try to be as upfront as possible to say what happened and what we've changed in the firmwares. There was another incident about 2 years ago when a company called Senrio contacted us and said they found a critical vulnerability. And we looked at it, and sure enough, there was a critical vulnerability, but it was in an open source component. It was in the GSOAP component, an integer overflow. So it was quite easy to fix, and we pushed it upstreams. But we're also part of a standard organization called ONVIF, a standard for video surveillance. And it's based on web services and SOAP. So we kind of knew that our competitors would use this as something similar. So we went into the ONVIF standard organization and told our competitors that you probably, if you're using GSOAP, you probably need to update. And we got a lot of positive feedback for that, not only from our competitors, but the market as well, because we showed that we take responsibility here. We really care about these things, even though it doesn't really affect us immediately. So based around these principles, we did our security development model that Stefan will talk about.
So Axis security development model. Why on earth did we come up with our own thing? One answer is because we could, but the other answer is that we really wanted something that was tailored to our culture and the technology stacks we were using. So it's super important for us to find something that's tuned to the way we're working. So that's the core for doing our own thing, instead of basing it on something Microsoft has done or something like that. More than 600 developers across 40 teams. How do we reach them with the gospel of security? It's a tricky thing. We need to prioritize the teams and the order in which we reach the teams. And the way we set that up is by creating an inventory of all our applications and services, making a simple risk assessment, and basically going for the teams developing high-risk components first. So in this figure, we basically went to our cloud teams first, and that's one of the reasons Svante is on stage. Because if something goes wrong in those high-risk systems, it has much greater consequences to our business. And that's been super important for us to be able to plan our work so we can systematically work through all these 600 developers across 40 teams. It's been quite a journey. The risk assessment we're doing for planning this is pretty simple. We're simply looking at the exposure of the system and the value it has to us as a company. So we're not kind of overdoing it. We're trying to make it lightweight and quick, and it's kind of inspired by CVSS. But essentially, that's the sort of risk assessment we're doing. So what do we actually want the teams to do? Unfortunately, there isn't a silver bullet for software security. So there isn't like a tool we could teach them or a technique or one thing they could do. Instead, we need a whole set of tools and techniques that can be applied when you do your architecture, when you develop your code, or even when you do your testing. So essentially, we needed to do a little bit of security work across the board, from architecture to code review to security. And the way you define that is again dependent on your culture. I mean, if you're a company that likes testing a lot, then you're probably going to do a lot of testing. But if you like to do code review a lot, you're going to do a lot of code review. So it really depends on your environment. So our security development model. We had two basic ideas when we did the first version of it. First of all, we wanted to keep it as simple as possible. We didn't want a lot of activities or a lot of tools, because that would be tricky to teach all the teams. And it could also potentially introduce bottlenecks within the teams. If they started to use all these new things, all of a sudden, all they would do would be security stuff. So we wanted to keep it to a minimum to sort of reduce the impact. The other main idea we had when we developed this is we really wanted to do security as early as possible in the development process. So we really, really want to build security in from design rather than try to bolt it on afterwards. So that was the two fundamental principles, which means that we're doing a small list of things. We're doing risk assessments, threat modeling, code review triggered from threat modeling. We do some testing triggered from threat modeling, internal pen tests. I'll talk a bit more about this, and hopefully we'll have some good examples for you on how that works. But when you use these tools and these techniques, there are a few other things you need to be aware of when you put something together into a security program. First of all, if you do architectural analysis, or you do security code review, or you do some testing, you actually need to understand the system. So you spend a lot of time trying to figure out how the system works, what the potential attacks are, and we want to share that knowledge. We don't want the testers to do that on their own, and then the architecture guys and developers do it in a separate silo. So we want to bring all that together. So knowledge sharing is super important for us. So all these things we're talking about, we basically try to do that in a collaborative way. So when you work with security, you're going to find some bugs and vulnerabilities. And you want to assign severity to those, basically to help you do the prioritization. So is it are we dealing with a high risk bug or a low severity bug? It's going to be quite important for how we handle it. And when we do that with several different techniques and methods and tools, we want it all to be calibrated. So we don't want the stuff that's found in testing to have a different severity than if we would find the same thing in architectural review, because that would make sense, because then we would start arguing internally. So calibrating severity is quite important to us. We're kind of inspired by CVSS, although we're not using it fully internally, but it's a good thing to base your thinking on external standards, because it also means that our internally calibrated severity matches what's being reported to us by external researchers. It's a good thing. It helps us out a bit. So the first thing in our security development model is risk assessment. So we do risk assessment on products or features to determine how much security work we want to do on that product or feature. So for us, risk assessment is a very quick way of figuring out how much effort do we need to spend to secure this thing. And in that analysis, we can come up with, we only need to do a code review, or we only need to do some internal pen testing, or we only need to do a threat model. It kind of depends, but we basically get this capability of tuning the security work to the risk of the thing we're working on. So basically, if it's a low-risk thing, we will do very little security work, preferably none at all, so the developers can go develop something useful instead of spending time on something where they wouldn't find anything. So risk assessment is super essential for us to have a grip on how much and where we spend our security efforts. So when we do it, we try to do this as quickly as possible. So it's basically a gut feeling decision. So if we have this new feature coming in, it's all a matter of the team getting a gut feeling whether this adds risk to the product they're working on or not. If they start doing a lot of analysis on this, they're actually going to spend a lot of time in vain. So we want really, really quick decisions. So when we teach this to the teams, we sort of say, that guys, you should time box this to 10 minutes, or at least that's what it says on our slides, but I usually provoke them and say, you got 10 seconds. Because in 10 seconds, you will know as a developer if the thing you're actually working on, it doesn't feel that bad, it doesn't feel that good from a security perspective, because all you guys, you already know this. So this just brings it up in the open. So risk assessment, essential for keeping track on how much security work we do. In our first version of our security model, threat modeling is the dominant tool. This is what we spend most time on. Basically, we do software-centric threat modeling, so we don't care too much about assets and threat actors. We look more on it from an architecture perspective. We draw data flow diagrams, and we come up with threats. When we think about the threats, we tend to look at it from two perspectives. So we have this little short list we give to the development teams. You should think about these things. But we designed it to be incomplete, so we force them to think for themselves. So they can't sort of just look at the checklist and figure out all the things they need to do. So they need to be on their toes. And we also try to gather a little bit of information from what teams have actually found. So some teams come across certain attack patterns, and then we feed that knowledge into the other teams. So the threat model generates threats, and that's where most of the time is spent. Once you've figured out what your threats are, it's pretty straightforward to define your countermeasures. And the countermeasures are essentially the security requirements of your feature. So this really empowers the teams, because there's nobody from the outside telling them what the security requirements for their component is, because they're going to figure it out for themselves by doing the threat model. And sometimes we find really interesting countermeasures. So I think Svante has a story for us, right?
Yeah. Sure. So one example of something we found pretty early during threat modeling was we had a cloud system that in a typical fashion nowadays had pretty many microservices behind an API gateway. And it was sort of unclear in the design documents where the session validation was supposed to take place. So each service did its own session validation of the incoming requests. This, in its turn, led to at least one of the services having incomplete session validation. So an unauthenticated attacker could basically act like any user of the system on this particular service. And this, in the end, led to a redesign of the whole system. So basically, we stamped down the session validation requirements in the API gateway to solve this.
So looking a little bit at threat modeling tooling. So the whiteboard, that's the best threat modeling tool. So what we do is we do sessions with the teams where we draw the architecture on a whiteboard. Typically, we have been a little bit inspired by mob programming, so we sort of do mob drawing and try to get the least skilled guy in the room do the drawing, and the team needs to collaborate. And basically, as the teams get more used to this way of describing their system, we start moving into digital formats. Some teams use Draw.io, some others use others. But basically, the whiteboard is a super powerful tool. So the result of the threat model, as I said, was a set of threats and countermeasures. But that's a very theoretical result. I mean, that's a result on a wiki page, because we're putting all our threat models on wiki pages. But that doesn't affect the security of our products. We really need to do real work items in the team backlogs for countermeasures that are missing or for test cases that are missing. Otherwise, we won't improve the security of our product. So the backlog integration is super important. I mean, I love threat modeling, but unless stuff gets fixed, it's a total waste of time. So threat modeling, how do we teach a team how to do threat modeling? Typically, we don't really believe in classical classroom training. So instead, we try to find a good feature that the team is working on. We try to collaborate with them and do the threat model together with them. So someone from the security team, me or Frederick or somebody else, we work together with the team, develop the threat model, and as the team gets better, we slowly start backing away and let them do it on their own. And before we leave, we try to do a short retrospect with the team to get their feedback on how threat modeling works for them. And basically, that's how we have built our entire threat modeling methodology. It's basically based on input from our teams. So threats and countermeasures. If you've built a countermeasure, you need to validate it and verify it somehow. You need to check that it actually does what it's supposed to do and that it actually exists. And you can do that in a wide range of ways. But one way of doing it is by triggering a code review from threat modeling. Since manual code reviews is a bit expensive, we try to do this as little as possible. And we try to do it where it really makes sense. So there are a few areas where it makes sense to trigger code reviews from threat models. One is, for instance, if you're encrypting something with an algorithm, and it's going to be pretty hard to look at the encrypted data to figure out what algorithm was used, so it's better to look at the code. Same thing for random number generators, and even input validation is a bit like that. I suppose your story is about input validation?
Yeah, so we were looking at one of our legacy systems that has been around for a while, so we weren't that sure of everything in it. And in this system, a user could share a public link to a certain surveillance clip, and another user could just use that link to look at it. And we had pretty good checks on authentication, but we only validated that the incoming resolution parameters were basically valid numbers. So an attacker could request that, say, the video would be upscaled to 3 by 3 million, and the media server would chug away and try to upscale it to that, which, of course, would bring it to a crash. So you could pretty easily DOS the system this way.
So another way of verifying your countermeasures defined in your threat model is classical testing. So you could do unit tests, module tests, system tests. Threat modeling tends to generate a lot of knowledge and a lot of test cases, so you really, really want to automate this. And we're trying to push as much as we can, as close to the developers as we can in unit tests and other automated test suites. And a funny side effect of this is that once a team has started doing this and they're getting a grip of their threats and they're starting to develop their test cases, they basically get their own little pen test suite going for their component. So you could argue that you don't need a pen tester anymore. I'll come back to that, but at least from a testing perspective, we don't. When it comes to testing, Svante, you had another story, right?
Yeah, so we were actually looking at one system that had a proxy to talk to all of our devices. And this was health checked via a service discovery system. And this service discovery system was set up to notify us when one of these device proxies went down so that all the cameras connected to it could be marked as disconnected. What actually happened was that interface was left open to the public. So via load balancer, you could request that interface, and that would mark all those devices as disconnected. But since the devices were actually connected, they would never reconnect. So you could basically trick the system into thinking that all devices connected to it were disconnected, and they would never come up again.
That's a scary story.
Yeah.
So I was kind of dissing pen testing, but now I'll bring it back up again. So we have found another use for pen testing. So what we do internally is that we use it to bring a gap in threat modeling. And the gap in threat modeling is actually the word modeling, because the threat model is based on a model of reality. So of course there's going to be errors in that model, and there's going to be gaps. So what we can do with internal pen testing is we can take a system for which we have done a threat model, we have done the threat model testing, we've done the code review, and then we can do our internal pen test. And then we basically get feedback from the internal pen tester, not only on the system, but also on how well we're doing the threat modeling. And this is a really good benefit for us, because pen testing is kind of expensive and time-consuming. So by getting this feedback on the methodology, we can improve the whole methodology, and all of a sudden we can get the scaling benefit from pen testing. So instead of doing it on a system-by-system perspective, we get our whole program to become much, much better. So far there's been a lot of talk about what the teams do, but there are others that need to help out with security. So when we do our security work and we start adding stuff to the team backlogs, we also get a grip for the remaining risk that we have in one of our systems or components. In this case, the light yellow is for medium risk findings, and darker yellow for high risk findings, and the red is for critical findings. And those are actual potential security vulnerabilities. They're kind of bugs in our code. The green line is super important, because that shows how much we're actually fixing. So a typical scenario is that we go to a team, we teach them to do threat modeling, they get great results, they feed it into their backlog, and their backlog is just filled up with security stuff that nobody fixes. And that's a really sad spot to be in. And the way we have tackled that is by making sure that our managers, product managers and line managers, they're actually responsible for the remaining risk in their systems. So they need to look at these types of graphs. They need to look at the bug count growing, and they need to take action. And in this figure, it's actually quite obvious what happened. So the team were finding things, and they were getting the time to fix things. So you basically get a reduced bug count on them. But it's key to get these other types of people in your organization on board on this. So you need everybody from the developers all the way to your managers. Final words?
Yeah, so this is Axis security story so far. It will continue on for quite a while, I'm sure. If there's one key takeaway from here, I think it is that if you want a security program, you need everyone on board, and you want it aligned to your organization's culture today, because it's really difficult to change an organization culture. If you want to add security to it, you're actually modifying it. So that's it.
Yeah.
Thank you.
Thanks for listening.